Hey everyone, Josh here. Today I want to give some updates to the MD-11, tell you about a couple new things that I've done. First I want to start out with something specific to the Pratt & Whitney engines. Now for those of you that don't know, all the parameters you see on these screens are custom calculated. They don't come from the sim, because what the sim does by default is not realistic. So these are all custom. And the Pratt & Whitney engines are controlled by engine pressure ratio, which is an indication of thrust produced by the engine. To simplify it, I mean, obviously, a little more goes into it than just that, but essentially it's an indication of thrust. So with the latest updates, the values are now correct in regards to how they adjust to different temperature. So we're on the ground here, and we're underneath our rated temperature of 30 C, which means that the engine is always able to provide 60,000 pounds of thrust, since we're pretty much at sea level. So as the temperature changes, you'll see, let's say we reduce it by 10 degrees, our EPR value remains constant because the thrust produced by the engine remains constant. Reduce it again, you'll see, still 1.61. But if we increase the temperature, let's go up to 30 C here. That's our limit here, where it's the highest temperature where we can achieve our 60,000 pounds takeoff thrust. If we now increase the temperature further, so let's add another 10 C here. Now you can see that the EPR has reduced because we are 10 degrees above our rated thrust temperature, which means that we are no longer able to achieve 60,000 pounds of thrust for takeoff. So now the EPR numbers reflect the thrust that is actually going to be delivered by the FlightGear properly, whereas before they would move around with temperature without respecting that linear relationship. And of course, if the temperature continues increasing, the numbers continue to reduce. The next thing I want to talk about is in the MCDU as well, so let's pop down here into this view, specifically regarding the optimum and max flight level. This is now implemented. So for this to work, the aircraft has to have some data about itself, so let's give it some data. And now you can see it shows us what our optimum and maximum flight levels are. Now I should note that this optimum value does not take into account the length of your route. So for example, if we were doing a short flight, flight level 390 may be too high for us. This is simply the optimum performance cruise level, aka the cruise level that will get us the best range and fuel efficiency. Now if you were to put in a cruise level above the max, let's say we put in 420, it's going to tell us that. It's going to tell us that our cruise is above our max flight level, but there's nothing actually stopping you from doing that. The aircraft won't limit itself to it, but it will warn you a couple of times that your flight level is too high. And of course, if you then put in a lower flight level, the message goes away on its own, as you saw there, because you're no longer above the max flight level. Another quick thing I want to mention is that the behavior regarding the way the PFD is drawn in certain cases has been improved. So you should see, well, I don't know if anyone will notice this besides me, but there are minor improvements to the animations on the PFD. A couple things are lined up a little closer to how they should be on the real airplane, and things like that. I've also implemented a fix where the flex temperature was not being reset by flight phases properly. So after landing, you could still see takeoff flex instead of takeoff revert there, so that's now been corrected. The next thing I want to mention is oil pressure. I've made a fix here, so let's go ahead, turn on the ignition, and obviously we got to give it a second for the packs to shut down there and for us to build our start pressure, and then let's start, let's say, engine 2. So I've also corrected the color of these switches. They should be orange, not red. They were red before. Now what you'll notice is that as the N2 starts to increase, the aircraft is going to start building oil pressure. So previously this was incorrect and it wasn't building oil pressure until actually lighting off, but you can see so we should have turned on fuel, but for now let's not. Even during just motoring phase, you can see it's starting to build oil pressure like the real airplane does. And then of course, when you start the engine and we get our EGT and fuel flow light off and all that stuff, you can see the oil pressure starts increasing much more rapidly. So for the next thing I want to show you, I got to put the aircraft on an approach, so give me just a moment to do that. Okay, so we're now on our approach here, and we have land armed. Now what I want to do is I want to have a look at the overhead. You can see that all the lights on the electrical panel are dark. And in this configuration, the ties are closed, which means that the buses are connected. Okay? So when this happens, this means that if one of these buses were to fail, the other bus can power its respective systems. Now what I want to show you is that when the aircraft enters dual land here, so we'll give it a moment to do that. There we go. We head back to the overhead. You can see that the bus ties have all turned off. And this happens to isolate each electrical system so that they are no longer connected together. And this is done because the autopilots, the two autopilots, are powered by different electrical buses. And if one of the buses fails, essentially this provides a way to make sure that, let's say, a short circuit or something on one bus isn't going to pull down the other bus. So if one autopilot fails because it loses power, the other autopilot can take over. So that's a requirement for dual land to engage. So let's have a look at the overhead here. And what I'm going to do is I'm going to put the system into manual, and I'm going to turn on one of the bus ties. And you can see that when I did that, it automatically reverted to single land because the redundancy of dual land is not available any longer. Now if we were to obviously put it back into auto, it can go back into dual land because the buses will split again, and this is true for any one of these bus ties. They'll kick it back into single land because it's not able to be redundant. But see, let's get that speed knocked down another 2 knots. You can see with dual land engaged, our buses are split, and the aircraft will perform an auto land, just like it always has. But I did want to add that that is now a requirement of the auto land system in order for it to work. So that's about all I really have to show you today. There's a lot of other small fixes to the aircraft, small changes, corrections, things like that. So keep up with the development if you're interested to see more. And yeah, that's about all I have for now, and I hope you enjoyed.